All right. So we got just a little disconnected. That's okay. I pulled a Mr. Boudry and my computer died in the middle of recording. So your last video left off me finishing with this, this problem. So volume is going to be the length 5 times the width, 7 times the height, 4. So in multiplication, order does not matter. So you just go from left to right. 5 times 7 is 35. Bring down the times 4. 35 times 4, well, I know that 35 times 2 is 70, and then 70 times 2 is 140. So the volume is 140 feet to the third. Make that 2 and 2 a 3, okay? Because we're in 3 dimensions now. Okay. Next prism on our list, we're going to go in order like I promised you, is a cylinder. It's like if I was to ask you how much can be in the Coke can. Okay. So cylinder. I keep saying Coke and it's LaCroix. I don't know why I keep saying that. I don't even drink Coke. I don't drink soda. It's just kind of weird that I'm like coming up with a random just soda drink and doing that. Okay. So cylinder. Let's draw one. Ooh, an actual cylinder. Thank you, John. So here's an actual cylinder. It has a circle base, circle top, height. Okay. So if I had this cylinder, John asked me to find. Okay. Draw a cylinder by like kind of curving the bottom a little bit. 2 lines up, a circle. So I'm going to challenge us a little bit. I'm going to go 8 yards. Would be like really long. Okay. That'd be 30, 24 feet across. So 8 yards. So I need to go back to my formula and they're asking me what is the volume of this container. Okay, this thing. Okay, circle. So I look back at my formula for volume for a cylinder and it says that it is the pi. It's the area of the base, okay, the area of the base is a circle, so pi times radius squared. The area of a circle is pi times radius squared times the height, correct? So I need to now plug in my information. Well, first, this person has to give me the height, or there's no way I can solve this problem. We'll say that this is 12, okay? So 12 yards, my bad. So volume is the pi, so remember we use 3.14 just so we can be consistent, times the radius squared. I gave you a tricky one. If all the way across, if the diameter is 8, what is the radius? 4. Radius is half times 4 squared times the height, and the height here is 12. Okay, so I got the 12 is the height, plug that in for height. Wah! And 8 was the diameter, so we cut it into 2 to get the radius. My arrows are throwing legs. Okay, now I have to follow the order of operations. I have to follow the order of operations. I took an oath in Ms. Minch's class. I don't just say I'm going to follow it and then don't do it. I follow it. I stick to my word. Okay, so parentheses, nope, exponents, yes. 4 times 4 is 16. So volume equals 3.14 times 16 times 12. Now, if all I have left is multiplication, now I can go from left to right. So I'm going to do 3.14 times 16 on my handy dandy calculator. 3.14 times 16 is 50.24. And I'm going to multiply that by 12, our height. And I'm going to get the volume is 602 and 88 hundredths. And then I put yards to the third because we're in 3 dimensions. So I took the area of the base. The area is a circle, pi r squared. Okay, if the diameter is 8, the radius is 4, pi r squared times the height. Area of the base times the height. Oh, sorry. Friend's asking me for a song. Yes, called. Okay, so now we're going to move on to the next one. We've done a cube, rectangular prism, heavy coaster holder, cylinder, circle top bottom. Next one we have is a triangular prism. It's the yummy, yummy, yummy Toblerone. John asked me if he could eat it when the video died, and I said, no, I have to use it for math, so he'll have to wait. Silly John. Okay. So example, we're going to do a triangular prism, TP, not like toilet paper because that's a cylinder, the triangular prism. Okay. So if I had a triangular prism here, ooh, like a tent. Okay, and this was 10 and this was 6, and this was, remember this height's important. Let's say it is 4. And if it doesn't have units, you know that later you add units, right? So, oh, that was supposed to be in green, oh well. So what is the volume? So I look back at my thing. If it's a prism, it's the area of the base times the height. Now, just because this Toblerone is lying flat, if you were looking at this image, kind of match, just because it's lying flat on the base of a rectangle, that does not mean that it is its base. Its base is actually the triangle. It's the shape that defines it. Okay, so even though it's lying flat, we could just take it and lift it up like this. So it's like taking that tent in your picture and lying it up like this. The area of the base is that triangle. Okay, so area of the base, which is 1/2 base times small height, and then times the big height, which is the height of the prism. So how tall it would be if it stood tall. So I'm going to take, I'm just gonna go for this. That is its height, because that is how tall it is if it was to be standing on its triangle. 6 is its little base there. 4 is its real height there. So I just plug those numbers in. So area of the base times height. So 1/2, I can put 0.5, times the base is 6, times this height of the triangle is 4, times the height of the prism is 10. Follow order of operations. If all you have is multiplication, you can go from left to right. 1/2 of 6 is 3. 3 times 4 is 12. 12 times 10 is 120. So the volume is 120. If it doesn't give you units, you put units to the third. I found this by doing the area of the base, 1/2 base times height as a triangle, times the height of the prism, okay? All right, next in our order is a sphere. Okay, sphere. Okay, if I was to find the volume of a sphere. Okay, and so how you can kind of draw that is just draw a circle and then just draw like a little dash through it. Kind of shows it's 3D. I don't know, come up with a better one and show me, guys. Drawing, you know, is not my strong suit. So let's say the radius is 10 miles. Okay, maybe we're talking about some sort of major thing. I don't know, asteroid. Matthew Resch, you always give me comments on these. Tell me if this is even accurate for an asteroid. I don't even know. Okay, you're my fact checker. I like it. Okay, so what is the volume? Dang it, it was supposed to be in green again. So I know that the volume of a sphere, if I look at my notes, is 4/3 times pi times the radius cubed. Well, the only thing I have to substitute really in here is this 10 for this radius, because the rest of it's just like constant numbers that are going to be there. So I can do 4/3, so that's 4/3, or 4 divided by 3, top divided by bottom, times pi, we're using 3.14, times the radius is halfway across, we're saying that's 10 to the third. Now, Ms. Minch has said this over and over, you have to follow the order of operations. So 10 to the third comes first because it has a power. Parentheses, exponents, multiplication or division, addition or subtraction from left to right. 10 to the third, 10 times 10 is 100. 100 times 10 is 1,000. Bring everything else down. Oops, I make that a 4. Silly goober. Okay, so now I'm going to do 4/3 times this. So in my calculator, I'm literally going to do top divided by bottom, 4 divided by 3. 4 divided by 3 gives me 4/3 times 3.14, and it gives me a rational number. It looks irrational, but it's a rational number because it does repeat, but it gives me a continuing decimal. So I'm just going to kind of round it for the sake of ease for this question. 4.186 with like a bunch of sixes times 1,000. So in my calculator, I hit equals and I hit times 1,000, and I get 4186.6 with a bunch of sixes repeating. So I put a little line there. I put a comma for that. And it was miles to the third because we're in 3 dimensions. So the volume of that planet or asteroid, Matthew will tell us later, that is 4,186.6 repetent miles to the third. Okay, that was a sphere. Next, cone. Now, these things, remember, when they go to a point, you divide by 3. Got to remember. Okay, a cone. So if I was trying to like find out how much ice cream I could get in my cone, so if I have this cone here and it comes down to a point, okay, That's supposed to be green. This page is purple. I just decided it's purple. If this is 7 meters, and this height, remember it's the height from the base to the point. From the base to the point, that's the height, not the slant height, the base to the point. And let's say that that is 12 meters. So if they ask me to find the volume, I'm gonna look back at my notes, but I remember that I do the area of the base times the height. This base that it lies flat on is a circle, so area of the base, area of a circle is pi times radius squared times the height of it, and then I have to divide it by 3 because it comes to a point. Area of the base times the height, and then divide by 3 when it's a cone. So now I know that this 7 is what I plug in for radius, and this 12 is what I plug in for the height. The rest of them are constants. That means there are numbers that will be there. So volume is pi. We can already substitute that by 3.14. Again, that's not accurate, but we just use it. Times the radius, 7 squared, times the height is 12, and then divide it all by 3 in the end. I have to follow order of operations or Miss Minch will cry. So before I do anything, I square this. 7 times itself twice is 49. So 3.14 times 49 times 12 divided by 3. And I just took 7 and squared it. That means I just took 7 and multiplied it by itself. Now I'm going to do the whole top and then divide it by the whole bottom. So in my calculator, I'm just going to do 3.14 times 49. 3.14 times 49 is 153.86 times 12 is 1846.32 divided by 3. That looks like a squared. Let me write that normal. That was 2 hundredths. Okay, now divide that by 3, hit enter, divide by 3, and I get 615.44, and then I need to use my units, meters to the third. So that is my volume of my ice cream cone. It's a lot of ice cream. Meters are like meter sticks, so it's kind of like a yard, kind of ish. It's the metric system, so that would be a lot of ice cream, but I would gladly do it if they asked me to. A more accurate answer even. So if like you look at this part of your finger right here, this is about 1 inch, which is about 2.54 centimeters. So that's a centimeter. So maybe like 7 centimeters. So that'd be like 5 centimeters, 7 centimeters. That's still a huge cone. So not accurate numbers, but it's an ice cream cone. I'd like to enjoy it someday in my life. Oh, we do have a cone. We have those cone cups. That's kind of a cone. Those blue and turquoise, the turquoise and pink cone cup we used for our wedding, that I wouldn't let us get rid of. No. We have ice cream cone cups because we didn't have ice cream at our, didn't have cake at our wedding because both of us hate cake, but we both love ice cream. So we had soft serve ice cream and snow cones at our wedding. They are? Yeah, they'd be up there in the very top with like the special cups. Okay. Now we have one more, and it's a square pyramid, a rectangular pyramid. You don't see it up there? Last one, rectangular pyramid. So I just look at my example. Remember this page is going to be blue because I'm just changing colors now. Rectangular pyramid. Okay. So if I had a rectangular pyramid, okay, this is 7, this is 8, and that height there is 14, I should say. Aha, thank you, John. It's a kind of cone. I mean, it's not really officially a cone, but now you can kind of see more how it's like a circle. And then it goes to a point, so then you have to divide. Because if it was a cylinder, it'd go straight down, but it's going in. This is what we had our HK in. Okay. So I have to, they asked me to find the volume. I need to go ahead and remember that it's the area of the base times the height, but it's going to a point, so I divide by 3. So I look here, and this is going to be the area of the base. So the area of the base, it's a rectangle, so length times width. Area of the base times how tall it is. Then I divide by 3. So length, width, height, and divide by 3. So now they're all constant. So I can start just plugging and chugging. So the volume is going to be length 7 times 8 times 14 divided by 3. So I follow order of operations. I do the top first. It's just multiplication. So now I just multiply 7 times 8 times 14. 7 times 8 times 14 is 784. I hit enter, and then I divide by 3 because it's going to a point, and I get a rational number because it repeats. And so then I get equals 261.3 repetent, and it doesn't have units, so I put units to the third. So the volume of that rectangular pyramid would be 261.3 units to the third. Oh, just highlighted in yellow. All right, so that's it for our volume, okay? So the big takeaway, the area, the volume of shapes of the area of the base, the thing it rests on, circle, square, triangle, triangle, cylinder, circle, rectangle, times how tall it is. Then if it goes to a point, you divide by 3. Sphere is the only weird one, 4/3 pi r cubed, okay? Thank you.